My name is Lars-Goran Magnusson. I work for Arctos Labs, and we're going to talk about the placement module and how that can help with optimize the distribution of the network services over a multi-VIM setup. So first we start with a bit of introduction to what this is, and then we will look at how it operates in OSM and so forth. This is a new feature that was recently then launched in OSM. It's available from release 8. So we'll do a bit of introduction here first, and then we'll look at how it's used. If we look at what we mean by this placement optimization, it's the process of deciding which VNF goes into which VIM in the situation where you set up multiple VIMs. If you look at the left-hand side, there's a illustration that comes from one of the latest white paper from the end user advisory group. And here you see that you typically can set up a different number of data center interconnected in different ways. So you might have a number of global data center, you might have some local data center, you might have some customer premises data center as it's called here. And when you get this more complex topology of the infrastructure, it also becomes a bit more complicated to really manually decide where things should go, and if things could go mostly in a global data center, in a local, or even further out at the edge. So optimal in this case is subject to what does the cost of compute in the VIMs, what is the cost of the links for the network service interworking between VIMs? Are there any constraints in the network service interworking, which could be currently then about latency and jitter? Not necessarily, but there could be things like that. And the placement feature makes this process automatic and optimal. You can, of course, if you have a network service that you want to deploy, you can decide, okay, this VNF should go in this data center, this other VNF should go in that other data center, and so forth. But with the placement feature, things can be more optimized and automatic, relieving the user from having to do these things. And then we'll talk a bit about the optimization process. So what we have here is first we have a network service, and of course up here on the left-hand side, in this case we have 3 VNFs. They may have some constraints on the links in terms of latency and jitter and so forth. We also have a model of the infrastructure where we have link characteristics. What is the latency and what is the jitter for a certain link? We then have costs associated with these things. How much does it cost to deploy a VNF to a particular VIM? How much does it cost to use a link between the VIMs? And the placement function will now consider all the VIMs available to the user. I mean, in your case, you have so far only used one VIM, but you can imagine a scenario that we showed on the previous page where you have multiple VIMs to choose between. The placement function will also then make sure that all the constraints are met, if there are any. It doesn't necessarily have to be that. And will then optimize on the cost what is the cheapest way that we can deploy this service over the available set of infrastructure? And internally, this is then modeled as a constraints optimization problem within the placement module. So that's sort of the algorithm that happens here. Things are modeled, and then we have a solver that computes the optimal solution to this particular placement problem then, as it is. So to summarize, we do computation of optimal placement of the VNFs over the available VIMs by matching the network service specific requirements to whatever infrastructure availability we have and runtime metrics of this infrastructure, while we consider the cost of compute and network. So a bit of different examples. We can have, of course, cost optimization only. We have a network service. We know that it costs differently to deploy it in different data center. Typically, it's maybe more cheap at more centralized data centers. No constraints, and then the placement module will then suggest or decide on a deployment just based on the cost. We can also have optimization, still a cost optimization, but with latency constraints. So we enter latency and jitter constraints for the links, the VLDs within the network service. And then we see, okay, where can this network service be distributed with as low cost as possible. This is sort of what we have today in the system. You could also imagine that in the future you could have different types of criteria. So one possible thing that you want to steer upon is utilization rather than cost. So maybe you want to fill up the data center maximum or so. And then we could imagine that the criteria is changed from cost to utilization, and we could still have constraints like in terms of latency or maybe other constraints in the future. This is of course another alternative that we have capability constraints. So rather than having latency constraints, maybe we could have some sort of capability constraints, which would then perhaps say that, oh, this particular VNF, it needs this particular support from the data center. It could be, for instance, GPU requirement if you have AI or ML applications that runs in your VNF, and then maybe they run better or actually even require a specific capability in the VIM in which they are deployed. So then you could imagine that we could have a number of different possible deployments, and then we could do capability matching, and based on that decide on where the service should optimally be deployed. And of course, you can combine this in different ways. Now we make examples with cost and utilization and so forth. So, I mean, in this case, maybe the capability could also be combined with utilization. But anyway, that's for future. Currently, we do cost optimization with latency and jitter constraints. So a bit of examples of some use cases then. When could this be useful? Well, for instance, if we look first, we have a UPF supporting low latency scenario. So we want to place the UPF as close to the customer that it has to be to achieve whatever latency constraints we might have in our service. So that's one possible example. Here we have another one, which is maybe also a bit interesting: deploy as far away as it can be. Because we can imagine that, for instance, if we have large centralized data center, maybe even then outside the operator's organization, it could still be possible to deploy network functionality in those data centers. So in this example, we have a placement of the core network VNFs where it's most efficient from your compute cost perspective. And then here we have transport optimization example. We have an IoT data processing VNF or application, which is beneficial to locate as close to the source of data to reduce the cost of transport or the load of transport. So that could also be one scenario where you would like to have some sort of automatic support for deciding what's the best possible location for our service and the VNFs in that service. Now everything has to start and end somewhere, so we have the ability to pin a VNF to specific data centers, and this could be, for instance, to pin a VM to or pin the VNF, sorry, to a VM with a specific VNF. Maybe it has to coexist with the location of the packet gateway. It could be that we have to pin it to a VM with connectivity to a specific PNF. It could be that we need to place something that's, for instance, have connectivity to a base station. Ultimately, I think in most of our cases here, we are talking about connectivity to a specific region or a specific area or a specific location. So there will be naturally some sort of anchors here that you need to consider when the network service is deployed. And then typically it could be an external system maybe that gives that information to OSM, because then the network service might be part of some bigger external service not visible to OSM, for instance. So in the examples here, we have one example where we say that, okay, VNF number 3 should go to VM number 3. The other VNFs can be freely placed, which means that they could end up in VM 3 or in VM 2 or in VM 1 if we say we have 3 different VMs. And the other example, we just say that oh, VNF number 1 must belong to this specific VM. Maybe because it's a customer location or something like that. Third example, no constraints for the pinning, free deploy among the available VMs, which will then mean that everything will be deployed in the cheapest VM from the compute cost perspective. So this is what it's about, as it says here, finding out where the VNFs should or must be deployed in a multi-VM infrastructure. We can look at some different scenarios maybe to make this more clear. Here's a view. We'll get back to this later also, I think. Here's a view of a topology of different data center and different costs and latencies associated with the connectivity between these data center, and we have a network service consisting of 3 different VNFs, and we have links between them like so. So in scenario A, we have no specific constraints or neither in terms of latency and so forth or pinning, which means that everything will end up where things are as cheap as possible, which means that in this particular situation, it will end up in the global data center. In the scenario B, we say that, the first VNF has to go to VIM number 3, which is down here. The other ones can be freely placed. And what will happen then is that things will actually be distributed. 1 VNF here, 1 VNF here, and 1 VNF here, because that's the most cost efficient deployment of this service. And that is maybe, even though this is a kind of simple layout and a simple example with just a few data center and just a limited number of links in between them, it's still not maybe obvious that that is the case, that it will be distributed that way. So I think it maybe shows the benefit of having this automated and supported by the system. So if we look at scenario C, let's say that, okay, we pin the first VNF to VIM number 4, but in this case, we put a latency requirement on the link between VNF number 2 and VNF number 3. Now this means that we can't really use this link, or we can't really use that link either, because they don't satisfy the latencies. We could put everything in VIM number 4, but that would not be the most cost efficient way. Instead, the most cost efficient way would be to put VNF number 1 in VIM number 4, because we have to do that, it's a must. And then, since VNF 2 and VNF 3 are free to place anywhere, they will go to the global data center, because then we satisfy the latency requirement and things will be as cheap as possible. So that's a word of some different scenarios that we could imagine and illustrate the different conditions and then the benefit you might have from having support to automate distributions like this. So next part here will come to how do you install and how do you configure this PLA module in OSM. This is a view of the PLA component, how it relates to its environment. I think this has been shown earlier in the week or in the introductory videos that you might have seen. So this is a new component. It's also optional, so you won't get it unless you specifically tells the installer to install it, and you do that by adding --PLA when you install OSM. To start with, we have maybe a bit limited and basic functionality initially. So this is sort of the first release where we have this feature. whereas all the other modules have sort of gone through evolution or a number of different releases. It works like so that whenever there's an instantiation request, we want to create a service, optional with constraints. Things go through MBI via LCM. LCM detects that, oh, the user did want to have placement support here, which is indicated by this entry in the config part of the nscreate command. So then it simply branches off to PLA, who does this optimization calculation and returns an answer to LCM, which then just continues with the service deployment using RO and so forth in the normal way. So the thing is that PLA in this case decides how to position the VNFs in the available infrastructure. So again, you don't have to use this even if you have placement installed. It's optional, and you invoke it at typically then at nscreate by adding this configuration part where we say placement engine is PLA, and then we can have our definition of the placement constraints and so forth. We'll look more into the different constraints later on. And as we said, these are given in the instantiation request. So we give the constraints here. And then the placement module will consider how do we distribute these VNFs of the VIMs available to the user. It interacts with LCM. It interacts with common services for the common database. Currently, that's the way it operates within OSM. We can maybe foresee a future where it will also interact with MON, having to do with getting to know the characteristics of the infrastructure, but also in future closed loop applications where OSM supports the service assurance using closed loops. Could also, of course, be human in the loop in some case, depending on the actions that needs to be taken. In order to get PLA to work, it needs configuration. We talked about that we have this view of prices. How much does it cost to deploy a VNF to a specific VIM? How much does it cost to use the connectivity, the links between different VIMs? So in order to do this, you need two different configuration files. One is called the VNF price list YAML. It's a YAML file. And the other is called price list YAML. It's for the interconnection links. So some sort of point of present interconnection link price list. These configuration files are in this release copied to the PLA container using simply Docker commands. So this is an example when you use Docker Swarm. If you have a K8s installation, you will have to identify the container a bit differently than you do here, but the concept is still the same. We just copy these files into the container at a specific location. So in the future, we will add NBI support for this, so it will be more sort of streamlined and integrated with OSM in a better way. So you can just do OSM PLA config, or whatever we will call it then. So if we look at the content of these files, then the price list for compute, that determines the price for each VNF at each VM. Also, you can do this per project, per user in OSM. So in this example, it's the same price, but it could be so that a particular user could have different cost models for deploying a VNF in different VMs. It could be that you want to sort of bias thing. It's important to remember that the cost doesn't necessarily have to be an absolute cost in dollars or euros. It could be a more abstract cost that governs the desired behavior, and then turns it more into some sort of deployment policy engine that you can use by just deciding to price things differently. It could of course also be that you have different, if you have commercial data center VMs, you might have different price lists, for instance, for different scenarios or different users. So basically this is how then the price list looks. We identify a VNF, VNFD, and we tell the system how much does it cost in different VMs. The same almost goes then for the transport between the interconnecting links between the VMs. So we describe the endpoints between two different VMs. What is the price? And also here we give the characteristics of this link. What is the latency and what is the jitter? And in current release, prices are given per link without any consideration to bandwidth or some other quality of service parameters or how much you consume and things like so. And as I mentioned before, in the current release, link characteristics are hard-coded. In future releases, this data should really be retrieved from the infrastructure by some sort of monitoring mechanism that will actually measure the current characteristics. What one can do for now, if one want to use this, is that you can just constantly keep updating these files, because they will be used or read at each invocation of placement. So that would be a different way to handle this kind of say live monitoring of the network then. So different ways to invoke this. We said that it's optional and you need to add this config entry. We in this case we just request cost optimization without any pinning or any constraints or anything like that. Everything is open for the placement module to decide where things should go. And then we can, and this is of course then more useful and really what should be used, and we can do request placement cost optimizing with pinning of a specified VNF, as we talked about before. In this case, we have an NSD where we have a VNF that we just call 1, and we say that, oh, it has to go to OpenStack 3, to that VM for a particular reason, like we discussed before, because it's connected to some endpoint that we absolutely must reach. And of course, we can then complicate things and say that here we have, in this situation, we have no pinning, but we have a lot of constraints for the links. So if they are distributed, latency requirements and jitter requirement has to be met. So that's one possibility. And then you can do a combination of these and say that, okay, we need to state that this particular VNF must go to a particular Vim, but we also need to consider these constraints for the virtual link. One, it has to satisfy these latency requirements. So you can combine this sort of freely, and I mean, now we show this from a CLI perspective, but you can add config information also from the graphical user interface, with or without the YAML file. It's possible to specify a configuration file that could contain this kind of information. So now we should have entered the hands-on session, but unfortunately we have to cancel this. To do the hands-on, we need a second Vim, right? We need at least 2 Vims for the placement module to choose deployment between. But unfortunately, our second Vim is at the moment not available in the Hackfest environment, so we can't reach that. So we have to do something different. This was a last minute cancellation, and sorry for that, but things happens in data centers. So the second Vim is not available. So what will happen now is I'll do just a walkthrough of the hands-on, and then I do some demonstration of placement in a separate context. But we can start with a walkthrough of the intended hands-on. You saw this slide also in Fernando's presentation about slicing. So the objective we would have had here in this hands-on would be to create a new slice, sharing the Magma orchestration, but automatically deployed to another DC. So in this case, we would have had a setup where the second Vim would be a low-cost Vim, as we called it, and therefore the subnet for the EPC would then have been deployed in the other data center, and this subnet, which is shared, as Fernando described and talked about, would then be used together with this new slice. So that was sort of the objective that we wanted to do here. So the step we would have taken to do this would first be to create that other Vim. So this is sort of same thing as you did when you created the Vim that you already use. Obviously another URL, but the same user, same password, same tenant. The naming is important because it must match the content of the price list file that we looked upon recently. So you would have used your just number here the same as you have the same as you have for your Hackfest users, for instance. And also you would have had to add this additional configuration to solve this. How do we resolve the networks when we don't know beforehand in which VIM, a particular network service, will be deployed? And then we would have to have collected the ID of this new VIM, because we need it in the next step. And that would be when we register the PDU to the second VIM account. So now we have this router that we have associated with the VIM that we're using for the slices in the previous session, for instance, and for all the other examples. In this case, we would have to create a new PDU. So edit the PDU YAML file, but change the VIM accounts to the new VIM in the VIM accounts list, and then just call the PDU create command, and then you would have had two PDUs associated in the system. And it would be possible to use the graphical user interface to do this also. And then we would have prepared for placement support. We would do this by modifying the configuration file. So we would have copied the param slices and made a param slices 2.yaml. In this one, we would have uncommented a few lines here. Placement engine PLA should then be uncommented, so that LCM knows that, okay, for this service instantiation, the user wants to have automatic placement support. And we would also have uncommented the VIM account ID, because we don't use that in this setup. Furthermore, we need another ID for the access gateway. So typically, maybe you have 100 here, and then we could have changed it to 101, both for the ID and the name. And the orchestrator IP would then be your IP address, for instance. And when all these preparations are done, we could just have created the slice in the same way as the slice was created in the previous session. We would have given it a different name. It's still the same network slice template. It's a different configuration file, because we have this configuration file now. And here you would have used your ordinary VIM accounts. And the thing would have been then that placement would have distributed this to a more to cheaper VIM, the low cost VIM that we never got to create. So that's basically it. The same thing here, almost, just that we tell the system to use placement, but a bit different result. So if you would have now done OSM VNF list, you would have seen that we can go back. You would have seen that the VNF associated with the EPC NSD would then be deployed in the new VIM, in the new low-cost VIM. So that was basically it for the hands-on. So the VIM account ID for this VNF should correspond to OpenStack X low cost. It would be the same orchestrator as before, so it should be possible also to configure and send traffic over this new slice. Maybe we haven't covered all that yet. And if you want to clean up, you would just have to delete the slice, just like so. So unfortunately, we couldn't do that today, but I can do some demonstrations of how this works. So this is we should go to some other. Let's see. We go here, or maybe I have it. Yeah, here. So we're now not in the Hackfest environment. So this is another environment that I have to just to show these things. Now you have to bear with me because this was sort of a last minute change we had to do because of the problems with the problems with the second Vim. So in this scenario or this setup, then we actually do have 4 different Vims, and they actually corresponds. Let me go back here. They actually correspond to this scenarios that we described here. So we have OpenStack 1 as the sort of a global data center, and then we have OpenStack 3 and 4 as some sort of customer premises location. So if we just go on and deploy according to scenario A, which would then be to call OSM-MS create, like so, and notice now that we're not doing slices now. We're now just looking at instantiation of a single network service. So if we were to do that, ignore the printouts. They are part of some troubleshooting efforts that was going on some time ago. Sorry, I hadn't cleaned up. I hadn't cleaned up the previous installation. So what we see here now is the new instance that we are instantiating. So we see that everything then goes into the same Vim. Everything goes into OpenStack 1 because we put no constraints or so forth here. And we can delete that to clean up. We should also, I think, have a B active that we can delete. So as expected, no constraints, neither for latency or pinning. Well, everything goes where things are the cheapest. But if we then just say that, okay, we must put the first VNF in the third Vim. So let me just see. I have this here, which is described like so. We have the configuration part here. We say placement engine PLA, and we say that, okay, we have this situation. The member VNF index 1 from this NSD, which is VNF 1, has to go to OpenStack 3. So if we run that, then we will see that, okay, number 1 goes to this Vim account. Which is then number 3, as we said. The other ones are free to deploy where it's most efficient, and then we can see that, oh, the system then decides that it's best to put the second VNF in OpenStack 2, which is then the local data center, and VNF number 3 should go in the global data center. So that's the most optimal distribution in this case. And then we can delete that, and then we can look at the final scenario. In this case, we make another pinning, but we put a constraint that these things, these two VNFs, for some reason, has to adhere to latency constraints, which means that they can't really be placed everywhere. We talked about this when we looked into this slide, that in this case they should probably go then into the global data center. So if we look into that situation like so, we have now a different scenario. We pin this, but to a different VIM. We now place a bit of constraint when it comes to one of the virtual links and say that latency has to be better than what we have here. And then when we run that, we can then see the distribution in this case it turns out to be cheapest in the local data center rather than in this data center. So it makes this decision then based on the view of the costs for compute and the view of the costs for transport and the constraints we have placed on the different aspects of the network service. In this case, then the specific latency. So again, we're sorry that we had this problem with the VIMs, so we had to cancel the hands-on. We anyway showed or discussed what would have been done and what would have been expected to happen, and then we had the other kind of demonstration and tying to one of the slides in the presentation. So I think that's about it. I haven't really had time to look at the chat. I see that Nishank has a question about the PLA descriptors and resources available in case you want to try outside of Hackfest. Yes, of course. You can also contact me on Slack and we can guide you. So these are usable things. It's included in the latest release, and you have to configure or write your configuration files for the PLA and install them, but then it's possible to use. Fernando, talk about the current release. You're talking about release 8. Yes, we're talking about release 8. So this is a new feature for release 8. So unless we have some additional questions right now, we can close and have a bit longer lunch. You can always continue to ask questions on Slack and so forth, and I'll try to answer them as they appear. So thank you for this session. Once again, we're sorry about the problems we had with the VIM setup today, but things like that could happen.